Hello, everybody, and welcome to the GraphQL workshop for June 1st. We have hit the 1st of June. I'm really happy that you all are here, and we're going to get right into it and get into a hands-on workshop all about GraphQL. So without any further ado, let's go ahead and get there. So my name is Eve Porcello. You can find me all over the internet at Eve Porcello. You can always send me an email at eve@moonhighway.com. No statute of limitations on that. You're always welcome to send me an email anytime with any questions that you might have. I wanted to take a quick second too to thank this.media and StepZen for putting on this event today. We're really excited to work with this on anything and super excited to be working with StepZen on this particular event. And everybody kind of got excited about some StepZen news about Node.js last week. So if you want to learn a little bit more about that, I would definitely check out their blog and social media. So I live here in Tahoe City, California, where I work at Moon Highway. Moon Highway is a JavaScript training company that focuses on Node.js and React and GraphQL and all sorts of things. We've taught some courses on LinkedIn Learning and Egghead.io. And we wrote a couple of books. One is about React, one is about GraphQL. We wrote the one about React twice. And you never know, we may write the one about GraphQL again too, because things change as time moves on. Little agenda for what we're going to cover today. We're going to get started with a look at the GraphQL query language. We then are going to move into the schema definition language. And then we're going to set up our own small GraphQL API with Apollo server. If you have any questions throughout any of this at all, always feel free to drop those in the chat. I see those right here on my second screen, so I'm happy to talk about specific stuff. This workshop doesn't really assume any prior knowledge about GraphQL, but we'll start from the beginning and get into some more advanced stuff. So, hey, Jessica, thanks for joining us and chiming in. So GraphQL is a query language for your API. So this is kind of the tagline for GraphQL. It's a language that allows for you to send a request and get back some data. It was created at Facebook, and GraphQL is a spec. It's a specification that describes everything that is part of the GraphQL query language as well as the schema definition language. So when you're getting started with GraphQL, and Jesse, your question, do you recommend we code along? Sure, absolutely. So this will be hands-on. You can definitely code along with me. I'm going to fire up some GraphQL playgrounds that we can use. And yeah, definitely. Another thing I wanted to mention is that this will be live on YouTube later. So if you have to pop off, or if you're like listening with one earphone in when you're supposed to be doing other stuff and you want to come back at a different time, you always can do that. So thank you for being here, but I totally get it if you have to watch back the playback later. Okay, so graphql.org. This is where the kind of documentation lives for the GraphQL website. You'll see me popping in with graphql.org there in the chat. Here you can find information about learning GraphQL. So all of the kind of basic documentation things are here. When you click on the link for code, this is going to give you a look at all of the different languages that are supported or that support GraphQL. So there's a ton of different tools out there in the ecosystem that you can choose from. Because I'm a JavaScript developer, we'll be focusing mainly on JavaScript, but you don't have to. You can always take what you've learned and apply it to Go or Python or whatever you want to use for developing your GraphQL solution. The other thing I want to point out here is that GraphQL is a spec. So you can read this cover to cover if you'd like to, but it really describes the query language and the type system or the schema definition language. These are the two kind of core pieces of what GraphQL actually is. And then from here, we get into that huge ecosystem of code libraries. So based on the query language and the schema definition language, people have built tools to solve all sorts of problems. So you can always check this out. The final thing I'll show you here on the GraphQL.org grand tour that I'm giving you here is that GraphQL is a foundation. It is not managed by any one company. I said it was created at Facebook, but GraphQL has a foundation that serves as kind of a neutral guiding body that everybody can contribute to. And that means you as well. So if you ever want to be part of kind of contributing code to open source, that it's a very welcoming community for that. And huge companies are involved and small companies are involved. So definitely check that out if you're interested. Okay, so that's the spec part. That's the website part. And I'm going to take you on a tour through the beginning of my slide deck again. Just remember we were talking about this stuff. That was fun. But basically, the reason that we use GraphQL is we're taking all of this data, all of the data sources that we have, REST APIs, databases, cloud services, and we're taking that data and putting it into a user interface. So we need some sort of a standard way of doing that, and GraphQL gives us a really nice way to handle it. Here on the left, you see our clients. So computers, phones, command line interfaces. We're going to send a query from those client side tools to a GraphQL server that sits in the middle. Then the GraphQL server is going to collect data from all of these different data sources and return that data in a single response to the clients. Another really nice thing about working with GraphQL is that it gives us a domain-specific language. So think about a domain-specific language as being like a language that everybody can understand. We can come together, let's say all of us are working on the same project together. We can design a schema in the schema definition language that describes all of our APIs types. So think about the types that you're working with. You might have users and products and cities and all sorts of different object types. Once you come up with the schema as a group together, everybody can go build their part of the application, knowing that it's based on that single schema. Okay, so it's the rule of GraphQL, unofficial rule, that you have to compare it to REST sometime in the first 10 minutes. So we're at 9:08. I think we're successful. The way that we get data with a REST API is we send a request to a route. So let's say I'm grabbing some information about a chairlift, a thing that takes you to the top of the mountain at a ski resort. We're going to make a request to /lift/panorama. Then we're going to get back this huge blob of JSON data. And no matter how many fields we want, we're going to get all of them back in this blob. Then if we wanted to get a little bit more data about trails off of the lift, so all of the pathways that take you to the bottom of the mountain, you're going to see that we have 4 different routes. And then we're going to need to make 4 different requests to those routes. And each time we make those requests, we're going to get back one of those huge JSON blobs. And that's pretty good. It works pretty well. But with each one of these requests, there's latency. So we're waiting on these bits of data to come, and then we're having to wait for each one of them. So then when we get all of these blobs of JSON, they're not ready to display. We need to sort it, parse it, filter it, turn it into the shape that we want, which is a lot of effort, particularly if we're using a phone on some sort of network. Here's where GraphQL comes into play. The way that we get data with GraphQL is that we send a query. Something to note about this is that we're still sending an HTTP request every time we send this query. So this query is going to be sent as a post request to a single GraphQL endpoint. So the single GraphQL endpoint is an important thing to note. The way that we're going to define what we want is with the query. So we'll ask specifically for those fields that we want and get back the JSON response and check it out. The JSON response is exactly the same as the query. No more fields than we asked for and no less. And that's pretty cool. And with this single endpoint, there's only going to be waiting for this single endpoint to return that data. Now, here's a super awesome thing about GraphQL. Instead of having to handle all of the sorting, parsing, and filtering on the client, we can move a lot of that logic, move a lot of that effort to the cloud, to some sort of server where we can predict how fast that will be a little better. Then we can use our devices simply for rendering. So this is a pretty cool benefit that we don't always think about when it comes to GraphQL. So, really good question here. Why is it a post request and not a get request? Ooh, I love StreamYard for that. Isn't that cool? So, it's a post request instead of a get request. If we go back to our, let's go back to our slide, because we need to post this query along with that HTTP request. So, when we send a query, and I'll show you this in a second, when we send a query to this endpoint, we also need to post the query. We're not just sending one operation and getting back a bunch of data. Instead, we need to define what fields exactly we need, and so it's sent as a post. So this is a sort of controversial thing, possibly, my statement here, because you can set up a query to be a GET request also. But 99 times out of 100, you're going to be sending it as a POST request because you need to post the body of the query along with that request. Really good question. Keep those coming as we're going along. No such thing as a bad question. If you're wondering, probably somebody else is wondering too. Okay. Let's talk a little bit about how we change data with REST. We will, in order to open one of these chairlifts, we're going to send a put request with a new status, and then we'll get back a huge blob of JSON. The way that we change data with GraphQL is that there's a totally different type of operation. A query gets data, a mutation changes data. So a mutation has a name, like set lift status. It takes in the name and the new status, and then it returns a little payload of data as well. So set lift status is our mutation. Again, it's sent as a post request. It's sent to this single endpoint. And the reason that the mutation looks like this is because that's how I set it up in the schema. Okay. So let's go ahead and take another look at this. We got our query. We're sending a query to a GraphQL server in the middle. That server collects the data from wherever it is, and it returns that data in a single response. So, Jesse, your question saying it's up to some sort of workers to send a response. The way that we can think about this is, let's say we send a query. We're asking for some chairlift data. We'll send this to the GraphQL server in the center, and every one of the fields that makes up that query, you can think about it as being backed by a function called a resolver. Now, a resolver function is just responsible for returning data from wherever it is. And this provides a lot of flexibility. Most of the questions I get about GraphQL are like, what database can I use? Do I have to use some sort of specific database? Or all my users are in a REST API and all of my product data is in a database. How do I work with this? We can use GraphQL as this layer in between all of our different data sources and the clients because these functions can return data from anywhere. So the query is, we're writing a query in that query language. The actual functions are written on the server, and I'll show you this today, of course. And these functions can then return data from anywhere. So there was a lot of conversation early on in the early days of GraphQL. You probably saw, these still exist today. You probably saw articles talking about how GraphQL is coming to kill REST and REST is over and we're not going to do REST anymore. Actually, More often than not, you will see architecturally some sort of GraphQL API sitting in front of a bunch of different data sources. And a lot of people don't want to fully take down their REST APIs, but they'll use the GraphQL server in front of it to query that. Okay, so that's a lot of talking that I've just done. And while I can't promise that I'll be done talking, I will give you something to do. So, couple things. Number one, let's go ahead and check out petlibrary.moonhighway.com. And I got a bunch of queries hanging out in here. So that's where we'll start is this link here, petlibrary.moonhighway.com. So what you can see here is the GraphQL playground. Think about the GraphQL playground as being an in-browser IDE that you can use to send queries to a GraphQL API. Now, in the center of the screen here is our GraphQL endpoint, the single endpoint. Sometimes this will end in /GraphQL, sometimes it'll just be at a single route, but whatever that is going to be here in the center. Over here on the left-hand side of the screen is where we're going to write our query. So let's go ahead and write our first query. So we'll write a query for total pets. Once I've written the query, think about the query as being the keyword that defines what type of operation it is. We're going to open and close a set of curly braces around the field that we want to ask for. So when we click play, we should see the response looks exactly like the query. No more fields than we asked for, no less. So that's a good question. Do we have to worry about CORS issues while using GraphQL? So yes. So typically when we're setting up our GraphQL APIs, we'll use some sort of a library or framework that helps us out with that. The framework I've used to set this particular one up is called Apollo Server. Apollo Server is a Node.js implementation of GraphQL. So this allows us to kind of bypass those CORS issues because those have all been handled by the Node server. But I would say that most libraries, most frameworks will sort out that problem for you because, yeah, no one likes dealing with CORS issues. Those are not fun. Not to say they don't exist, but a lot of those rough edges have been sanded off by library authors that are hooking us up with these great tools. Okay, so this is our first query. We've asked for total pets. We get back total pets. So the API that we're using here is all about pets, right? The pet library we can think about as being like a library where we check out books, but instead of checking out books, we're checking out pets. So I can add on to this query to get a little bit more information. Here on line 2, we have our query for all pets. And then what I want from all pets is I want the name and the weight and the ID. Once I click play, check it out, we have an array of objects where only the fields I've asked for are here. We could potentially have 1,000 fields on a pet. That would be a pretty data-rich pet, but we could have a bunch of fields, right? When I ask for these fields in the query, though, I'm being ultra specific about exactly what I want, and then I won't get anything extra. Okay, so how do I know what these queries are? Let's say we weren't the architects of the pet library and we want to take a look at what's available here to be queried. So over here on the right-hand side of the screen, you'll notice there's a panel called Docs. So you can go ahead and click that open. This is going to list all of the different queries that are available on this API. So we've already sent the query for total pets. Total pets returns an int. We also see here the query for all pets. So all pets returns a list. We know it's a list because we see those array brackets there. And then we also see an exclamation mark inside and outside those brackets. So anytime we see an exclamation mark in the GraphQL schema definition language, we're going to know that this is non-nullable. It's required. We must have a value for this that isn't null and that matches the type that we're using. So even though we're just starting to get introduced to this stuff, we're starting to see how the schema that is backing up this server, it really enforces a type system for this API. So we often think about GraphQL as the query language, but if you like types, you probably are going to like GraphQL because we have so much type enforcement going on. Yeah, and it's such a cool docs layout, right? Very, very cool. So this is our documentation panel. You also can look at the schema document that backs this whole thing up too, but I really like the docs panel. I've used a lot of REST APIs where I'm constantly like pinging the API, seeing what's available, which is fun. It's a fun little task to do. But being able to see this in the layout is pretty incredible. Okay. So we can use this documentation panel anytime you're being introduced to a GraphQL API for the first time. You can use that. There's also the option you can hit control space inside of any one of your queries. So what I mean by inside is whenever you're inside of a set of curly braces, you can hit control space and that'll show you everything. So let's say we wanted to add category. I'm going to click play on that. And here we see cat, we see dog, we see stingray, and rabbit. So these are all the animals that are available for us at the pet library, all the pets. So all pets here, right? This is returning the pet type. So we can think about this pet type as being kind of the core type for this API. Inside of this type, we have a category called pet category. So unlike name, which is a string, it's just any sort of string value, pet category is actually a restricted list of options for this field called an enumeration type. So I think about this a lot of times like a drop-down list. Picture like you have a cool front end for your pet library and there's only a drop-down for these 4 values. So this is a really nice thing to enforce that sort of restriction on a particular field. So that is an enum type, a GraphQL enumeration type. Everybody pronounces this word a different way, so I always say it, the long version of it. Yeah. So really good question about our query language over here, Jesse. I'm going to pop this up because I think it's fun to use. No need to separate properties by a comma. It's implied by carriage return. So, yes, if you take a look at that spec that I showed you earlier with the query language, you will find out that if I trip and put an elbow onto, or like my cat walks on my keyboard or something, and I put a million commas in here, commas are totally ignored by the GraphQL query language. So we just skip over those and the query executes as we expect it to. So sometimes you'll see folks separate these with commas, but really those are fully overlooked. So ideally, we want to be as terse as possible. Remember, we're writing a query, which is declarative. So we're declaring exactly what fields we need, and then we'll leave it up to the server to return the data for me. So with that specific nature, with the kind of terse syntax of the query language, all of these are just being ignored. Let's add on to our query a little bit. I'm going to bump total pets. I'm going to take this up to the top of the query scope just so that we can see what's being returned a little more easily. Here we have a query for total pets that's returning 25. But if I go over to our documentation panel again and we take a look at total pets, check it out. We see a status here called pet status that is an optional status argument that we can send to this query. What am I talking about? Great question. We're going to go ahead and add a status here. as an argument or a filter to this query. As soon as I add this status here and I click play, we're going to see that there's only 2 available pets currently at the pet library. That's kind of funny. This is a live API, so people are constantly checking out pets over here. You also could send a status for checked out. And all these pop-ups will show up for a minute, but then we can finally get these back. So this is an argument. When we send an argument, think of it as being like a filter to return kind of a filtered list of results. Let's consider a situation though where we want to send a query, total pets, or a status available and status checked out. As soon as we do this, we notice something kind of upset over here. We notice a little red box next to our 2. Then when we click play, we're seeing an error. So this says fields total pets conflict because they have differing arguments. Use different aliases on the fields to fetch both if this was intentional. So what this is saying is that because I'm sending the same query with 2 different arguments, there is a conflict here. So I could just delete one of these, send them one at a time, and give up, but I don't want to give up. So let's preface this field with a different name. I'm adding here available, and then I'm adding checked out. Checked out. There we go. So when I preface both of these, with an alias, we're going to be able to send the query, and we'll notice a couple things. Number one, the query works. We're able to see this, but we also see that the field has been renamed in the response. So this is kind of an interesting thing. It's called a GraphQL alias in the query language. And the query language here is going to allow you to send 2 of the same query with different arguments, provided that we give an alias to that field. That can be whatever you want to call it. And you also can add this to any field. So I could say first name. Let's say I really want to call this field first name for each one of our pets instead of just name. We can do that quite easily. Just preface the field with first name, and then we're going to see that. Let's see. So why are some of the types have an exclamation mark? Yeah, so the exclamation mark, whenever we see this, it just means that it can't return null. So total pets, for example, it returns an int, int, and that has an exclamation mark after it. So what this means is if this returned null, then there would be an error. Similarly, we can have nullability. We can have an exclamation mark on specific fields. So what this means is that if name returns no, if it returns null, if it returns no value, then that will cause an error as well. So not only are you enforcing types for your fields, you're also enforcing nullability. So we could talk all day about what's the right way to handle that. I would say when you're designing your schema, you want to be just really careful with making everything required. Sometimes it's not truly required. Maybe a name and an ID are required, but other things are not. So that's really up to you as you're designing your schema, but it will start to cause errors if you return null. So that's just something to be aware of. With all things we're doing, just as an aside, with all things we're doing, we're trying to be as communicative as possible when we're designing our own schemas. And the reason that I say that is because think about your schema as being a way of communicating what are the types that are available. You want to take a lot of time to design your schema with good naming conventions. And by good naming conventions, that seems like there are set rules for handling that. And it's really more like just name stuff, something that makes sense to people. Total pets, that's kind of sensible. A good example of this is there's a query here called pet by ID. In my early days of using GraphQL, I used to call a field like this pet or capital P pet or something like that. Lately, I've been calling it pet by ID. Very clear to the user, the consumer of this API, what this is called. So you can give your consumers a break by naming things really, really well and thinking about how this is going to be consumed. Okay. So pet by ID, I kind of glossed over. We sent an ID to this query. Then we added a name here. So what the pet by ID query is returning is it's returning a single pet, a single object, and that object is non-nullable. So if I send this query, unlike the all pets query, which returns a list, this is just going to return a single object. Okay. So here's something that I would like to do. I'm going to leave my pet library up. I'm going to pull up another one of these playgrounds, and it says vote.moonhighway.com. Now, vote.moonhighway.com is the API that's powering this beautiful user interface over here. Long story short about what this app is, my husband Alex and I were hosting a React conference called Reactathon in San Francisco when you could go to conferences in person. But I feel like that's coming back sometime soon, hopefully. And the Reactathon conference was an event that had two hosts, Alex and me. And we wanted to have a vote that would be decided with GraphQL about who should host the rest of the conference. A very ridiculous prospect. However, it was fun to use GraphQL to get everybody to vote. So a task that you will probably be asked to perform at some point in your life as a developer or a product manager or really anybody who's dealing with data is you're going to be sent a link like this, and you're going to have to find some information from it. So because we have this nifty docs panel, we're going to be able to kind of view which types of queries and mutations that we can send. Remember that queries get data. So we can send a query here for results. When I click this play button, it's going to send an HTTP request to return this data. So that's a query. Queries are responsible for getting data. We are sending it as a post request because we post the body of the query along with the request. As I mentioned in the slides earlier, though, there's another type of operation called a mutation. Think of a mutation as being all of the verbs, all of the actions that are associated with your API. And we're going to go ahead and add a mutation called vote. The vote mutation, if we look at the documentation panel, takes in a host. And a host is an enumeration type, if we scroll all the way to the bottom. A host is an enumeration type that's either Alex or Eve. So remember, that's just that restricted list of options for that field. I swiped away from it, but we're back. And let's go ahead and vote for Alex. He's not here. He's downstairs, but we can go ahead and vote a couple different times. And this mutation is going to then affect our total. So people are voting. That's fun. So yeah, every time we send that operation name, we're going to be able to see that vote total change. So queries get data. Mutations change data. There is a third type of GraphQL operation that is actually putting in work right now. So let's go ahead and add it. It's called a GraphQL subscription. So I'm going to add the subscription here. A subscription has a name, just like a query or a mutation. But we want to think about a subscription as being a real-time operation. Let me show you what I mean by that. When I click play, we're listening. And I know we have a lot of voters out there, so if anybody wants to send a vote to make it look like this works, I can do it myself too. But when I send this subscription, we're listening. We're listening for any sort of data changes. So if I send a couple different mutations here, this is going to, every time there's a new mutation operation, it's going to pass those back to the client in real time. Subscriptions, unlike queries and mutations, they don't work over HTTP, but they work over WebSockets. So check it out. If I send a query, right? We send it, we get back a response. When I send a mutation, we send it, we get back a response. With a subscription, though, we click play, and I'm going to refresh this and start that anew. We click play and we're listening. So I kind of think about it like a phone call. We're listening. I call you up and I'm like, is there any new news? And I just wait for you to tell me that there is. It's not like, what's the news? And then I hang up. It's more like we're opening up this channel of communication where all of these results are coming back in real time. So this is a two-way street, sort of. We have the subscription on the server, so we listen for those data changes, but this is also working on the client as well. So if you vote, thank you for voting. As people vote, it will update the UI in real time as well. GraphQL subscriptions were used for the first time at Facebook when they were rolling out that live likes feature. That's just, I put my thumbs up, but that's just if a bunch of likes are coming in, there's a new thumbs up that pops up. You also see it on those videos, those live videos where little emoji heads float all over the screen. So these are being used in real time for real at scale in production. So GraphQL subscriptions are pretty cool. Just to recap, queries, they get data. Mutations change data. Subscriptions are going to listen for data changes in real time. So there's a great question here. Does GraphQL provide any built-in helpers to convert weight and date? So this is a really great question. If we take a look at the documentation panel, and I'm going to go back to our pet library for this, we see a couple of different types that are being returned for single fields. Think about them like this. If we scroll down to our pet, we see ID, we see string, we see float, we see Booleans, whether or not the pet is late. So ID, string, Boolean, float, and int, these are the 5 built-in scalar types that are part of GraphQL. You'll also notice, though, on our customer type, we have a field called date created. And date created returns a date. So it is possible to use different scalars. You can customize your own to work in the way that you'd like them to, or you can use packages. There's one called GraphQL Scalars. That's a pretty popular one. And this allows for you to create custom scalar types for some of those built-ins, things like email addresses or URLs. Basically, the difference in the case where you might want to use a custom scalar is if you're dealing with a type that has a little bit more semantic meaning than maybe a traditional string. So a name is a string, right? The date, it is sort of like a string, but it means something specific, and we want to parse it and validate it as such. So this is something to definitely check out. I'm going to send GraphQL scalars if you want to dig a little bit deeper on that. Another question I see here is the response is pretty fast for our GraphQL subscriptions. And the answer is yeah. So GraphQL subscriptions work very well out of the box, but a lot of the questions that come up about scaling GraphQL and all sorts of kind of infrastructure questions with GraphQL, we still will have to scale these out. For example, if we set up a subscription server for this voting app, this is only going to be working on one instance unless we put this on more instances and create a persistent data layer to monitor all these subscription changes. So GraphQL doesn't do all of that for you, but it does provide kind of the framework for how this works. And by framework, I don't mean like framework. I mean, it provides the primitives for the subscription type. And it also will allow you to trigger those subscriptions with mutations. So the pet library at this phase doesn't include subscriptions, but these can be added to absolutely any server. Okay. Here's what I'd like to do. I'm going to open up a new tab. We're back over to our pet library. And we're going to go ahead and send a query. The query I want to send is for all customers. So far, we've talked about the pet type, and that's fairly cool. But the real kind of exciting power of GraphQL starts to show up when you start talking about different types and how these different types relate to one another. So here we have our query for all customers. And then there's another field here called current pets. The way that the customer type and the pet type are connected are on a field here called current pets. So if we take a look at our documentation panel, we click on all customers, we check out our customer type, and then we check out current pets. This is returning a list of pet objects. So I can then add another nested set of curly braces and return the name for each one of those pets. So once I click play on that, we're going to see that if they have a pet currently checked out, it's going to be added to that array. Remember, even though current pets should, let's see, customer, current pets, even though current pets says non-null, we see those exclamation marks, so we know that those are required. This is going to be an okay value because an empty array is truthy. It's a value that is not null. And so this is why that's why we can get away with that. So an empty array, remember, is not null. So that is totally fine. This is how the relationship between the customers and the pets work. It's on that specific field. Similarly, though, we could add to our pet by ID. And we'll see if this person or if this pet is checked out, hopefully. The other connection back to the pet is on this field called in care of. The customer could return as many pets as they wanted to. In care of, each individual pet is only going to be able to return one of these pets. So if I click play on this, we'll see that this pet in particular has been checked out by Veronica. Pretty cool. Nice. So feel free to keep those questions coming. I am going to turn you loose on a little activity. So what I'll do is I'll pull this up on the screen. And like I have said a couple of times, the way that we're going to interact with data in the future, it's not all going to be REST anymore. We're often going to be given a URL, something like this, and we're going to be tasked with asking that GraphQL API for a little bit of information. So I've sent that link to you in the chat. We're going to go to snowtooth.moonhighway.com. This is a fake ski resort with a real GraphQL API. And I'd like for you to try these steps. So first, we want to write a query to get all the lifts with their name, elevation, gain, and status. Then we want to extend the query to find the trails off of each of those lifts. And then if you have some extra time, we'll change the status of one of the lifts. Okay. So I'm going to give you, I don't know, 5 minutes to work on that. You can always share your answer in the chat if you'd like to. But let's start there. I'm going to, in a couple minutes, start to go over the solution, but I want to give you a moment to try that out for yourself. So again, we're going to that URL, we're writing a couple queries, and then we'll write a mutation to change some data. Give it a try. If you get stuck, let me know. Very nice. All right, let's take a look at this. If you're not 100% done, that is totally fine. But we are going to go on a bit of a tour of some of these features here, these snowtooth.moonhighway.com, some of these types, I should say. Let me close these two tabs. And what we're going to do is write a query for all lifts. And if you're sharing your answers, that's amazing. Thank you for doing that. It looks so good. The first thing we wanted to do was to send a query for all lifts with their name, elevation gain, and status for each one. So once I click play on that, we should see our array of objects coming back, and then we have just those fields for each one. The next thing we wanted to do was to extend the query to find the trails off of each one of those lifts, and I'm just 5 stars all around. This is looking so good. I never told you what fields I wanted off of the trail access field because I don't really care. What I do care about is that we're connecting the pieces of data. So as long as we added this trail access field, remember, fields are how we connect different types with GraphQL. So the lifts and the trails are connected based on this single field. So this also returns a list. For each one of these objects, we have just the name and the status being returned. And again, if you didn't have a chance to get to this step, that's totally fine. Okay. The final thing we wanted to do was to change the status of one of the lifts. So all lifts gives us this data. We can also send, and let me put it on the same tab. So you can always copy and paste the answer that your fellow students have added here. I just added what I have to our chat there. You're also noticing that just by virtue of the just by virtue of pasting things into YouTube's chat there, it might have made your query look more like this. So when the query is parsed by the server, it's just looking for a space. So the space separation is all that's important. We saw before how commas are completely overlooked. Extra spaces are okay too. That's just something to be aware of. Okay. Yeah, so the mutation piece, let's go through that together. We want to create a mutation for changing the status of one of the lifts. So this is a little tricky. The first thing we want to do here is we want to, and I'll put it in a new tab because we shared the answers to the previous ones. So if you need to catch up with those, that is there for you. So the mutation has the mutation keyword, and there's a query here called, or mutation rather, called set lift status. Now, whenever we're investigating one of these APIs for the first time, we can check out what we need to send. So this looks like we need to send a query for, or an argument rather, for an ID. And we also need to send an argument for lift status. So if we go back to the all lifts query over here, I'm going to add this field for ID. So this is going to tell me all of the IDs. It's lowercase. I'll just start with the first one, I suppose, Astra Express. So set lift status, we open and close a set of parentheses here. And I'm going to add ID, Astra Express. And then we're also going to add a status. When we're sending a status, that's an enumeration type. And we can check out the statuses over here too. So status, I guess we had that already. We notice though, if I put more than one of the same field in the query, okay, we're only going to get it back once. So it looks like we have open and we have closed. It's a little confusing with the trails in here too. Let's check this out. You always can check out the docs as well. So if I look for status, lift status, it's open and closed and hold. So let's go ahead and change the status to hold. Keep in mind that this is a live API. This is live data. So sometimes we'll have folks in class who send a mutation and they're like, I changed it to closed and it says it's on hold. And that's just because somebody else probably changed it right in between when you did it. So we're going to click play. We'll grab the name and the status. And then we'll be able to see that that has indeed been changed. So something that's really important about this, a mutation returns something. This can feel like a little bit of a mental shift, particularly if we're used to REST. The thing that this returns is some sort of object. At the time that I send the set lift status mutation. Hold on, I'm going to drink water so I don't choke live on camera. Yikes. So we send the ID and the status, and then we return an entire lift object. So this is why we need to use the curly braces to return something. If you recall back to when we sent the vote mutation with the voting app, let's see if it's still here. It's not, but we can get it back. Check it out. Vote, we didn't have to use a set of curly braces. And that was because the vote mutation returned a string. The set lift status mutation returns an entire object. So this is why we need to use this. You'll find out pretty quickly if you don't return that. If you don't return something, you're going to get a message saying that, hey, we need to select some subfields here, and then you can quickly add them and return fields from that type. So that's what that's all about. Jessica, your question is such a good one. Let's blast that up on the screen. So why aren't single quotes allowed, like ID Astra Express? The error message says, and let me mimic this with you. It says unexpected single quote character. Did you mean to use a double quote? Yes. So unlike JavaScript, which is open season on using single quotes and double quotes interchangeably, in the GraphQL query language, which is a different language that's defined by that specification that I shared, you can only use double quotes. So that's just a decision that they made when working with or when designing the GraphQL query language. We got to use the double quotes instead of single quotes. You also, if you've used like template strings in JavaScript with the backticks, you're not going to be able to get away with that either. That actually won't even let me send the query. So that's what the double quotes are all about. There's strange pickiness around that. You also you'll see how there's pickiness around like this sort of nesting. And yeah, Jesse, as you said, plays well with JSON, I suppose. Absolutely. So I want to make one more adjustment to this mutation. And this adjustment is going to mean that we're not going to send these arguments as, we're not going to send these arguments in line on lines 3 and 4. Instead, we're going to set up this mutation to handle variables. So what do I mean by that? Let's think about any user interface that we come to. Let's say we have a nice UI that we can set the lift status. I'll pick Astra Express, and then I will select what the new status should be. I would like to make that a little bit more dynamic. I want to make this mutation more dynamic. So we're going to set this up to accept variables. And it's going to look like this. So we're going to create a variable for an ID. This can be called whatever you want it to be called, but usually I just call it whatever the name of the field is. Some people don't agree with that pattern, but that's whatever you want to call it is the point. Then we also need to define the type. So the way you can find the type is just take a look at the documentation. Here we're going to say ID, and we're going to do the same for status. All right, get out of here. And then the status for this one is lift status, but with an exclamation mark as well. So let's go ahead and add that, lift status. I'm going to make that a little smaller. Now, because we're not kind of hard coding this into the mutation, we're going to say that the ID takes in the variable ID and status takes in the status. This is ready to go-ish. It's ready to accept input, but we need to provide that input. It's saying that the variable for ID doesn't have an ID that's provided. So let's open up the query variables panel and we're going to show how to send these as JSON. So here in the query variables panel, we'll pass an ID and we'll pass it for a different lift. And then for status, we need to pass this in as JSON. So it's important to note that we need to use double quotes around our keys and double quotes around our values. So now when I click play, this should change that status. So essentially what we're doing is we're just setting up our query for dynamic input. You can think about this as eventually being connected to some sort of a front end where we might have a lift status that we're collecting from our users. And then this query will make that work for this purpose. Okay, cool. We would like to see a query that will select multiple elements, like with status of hold to mutate it to close. So you can definitely do that. You can set up your mutations to perhaps just mutate the hold ones and change it to hold, or change it to closed rather. That's actually a great idea for one. The place that you would need to set this up is in the schema. So a lot of times questions that will get related to GraphQL are like, why does it work like this? Can't we send multiple statuses, or I want to send a mutation or I want to send a query rather that returns all the lifts where the status is either hold or closed? Or is there some way to do that? And the answer is there is, but we would need to set this up at the schema level. So what I mean by that is we need to build that into the schema to accept that type of input. So all you would need to do for that is you would, in your query type, and I'm going to show you how to create some of these queries in a second. So all we would need to do is we would create a query for all lifts. And then inside of the all lifts arguments, we would say, instead of just accepting one lift status, we want to accept an array. So a lot of flexibility with our schema, but we just have to build it in order to make that query work. So oftentimes that would look something like this: hold and closed. This is showing an error. That little red box is back because I haven't set up my API to work this way, but this is how this would look if I had. Cool. All right. So that's a quick look at our GraphQL query language. Maybe not that quick. A 1-hour look at our query language. These skills that you're learning are the building blocks of everything that you'll do with GraphQL. And the reason why I say that is because no matter what you're building with GraphQL, you are going to have the ability to do a lot if you have a good command of this query language. So another question that popped up: how to change the status of all records to hold. Yeah, we would just want to create a query or a mutation for that. You, inside of your mutation type, would set up a mutation that would change all the records to hold. You could say set all to hold. So that's what that would look like. Hey, Conrad, how's it going? Nice to see familiar faces popping up. So that's what that's all about. Think about, think about anything that you're doing with GraphQL as being kind of based on that query language. A great example of this is the GitHub API. Versions 1 through 3 of the GitHub API were all based on REST. So we would send REST requests to interact with all of the objects that are part of the GitHub universe. Then with version 4 of the GitHub GraphQL API, we got this awesome interactive tool that we could use to interface with our GraphQL or with our GitHub objects. So all you need to do to sign into this, and let me pull this up for everybody. So this is what I'm using here is the GitHub GraphQL API. I'm going to click sign in with GitHub. And then this is going to show me a nice little explorer that we can use to interact with this GraphQL data. It has a pre-formed query here for you. So I can click play, and this will show me information about our viewer. So think of the viewer as being just the person who's currently logged in. This is you, this is me. And the query here we can then add on to, and we can interact with all of this stuff based on what we know from the query language. It's really important to respect the query language. That's ridiculous. But it's very important to learn the query language because having a good knowledge of how to interact with this stuff is going to help you in more context than you think. So this is the GitHub Graphical Explorer. Graphical is just like the playground, but it just doesn't have the nice little UI. The one that we're just looking at is here, the snowtooth.moonhighway.com. This is the GraphQL playground that you can use to interact with some of this stuff too. Okay. So let's go ahead and for the remaining time today, I want to show you how to create your own GraphQL API. There are many different tools that you can use to make this happen, and this is something that we talked about at the beginning of the workshop today. If you click on graphql.org, the code link, graphql.org/code, this is going to show you everything that you could choose from as far as putting together your own GraphQL API. The tool that I'm going to use for this is called Apollo Server. So Apollo Server is a great library that we can use to build a Node.js server that serves up some data in a GraphQL way to any sort of client. So the way that I'm going to get started with this is I'm going to pull up a link to a code sandbox that we can all use as a starting point. And I just closed the window that I had it open on. I need elevator music for a moment. So yeah, you can install GraphQL Playground if you want to as a desktop application. I typically don't use it that way, but a lot of people do. Usually I'll just fire up the browser and use it, but that's entirely up to you. And great. Kamal, you're sharing the how to brew install that, and that's really cool. Good stuff. Okay. So for our final little exploration of the world of GraphQL, I just shared with everybody a link to a code sandbox. And this is going to be our starting point for doing this work. So let's go ahead and visit that. What you'll do if you haven't used Code Sandbox before is you can log in with your GitHub account. It's free to join Code Sandbox. But once you do that, you can click on Fork up here in the upper right-hand corner. And that's going to create your own branch of this project that you can use. Your own fork of this project is a better thing to say. But this will fork this open to your own environment there. And then the other thing I want to do is kind of give a tour of these files. So here we have an index.js file. The dependencies that I have installed are Apollo Server, GraphQL, and NodeMon, which is just going to restart our server. And we also have some data here. So inside the data folder, we have a file called lifts, and we have a file called trails. This data should look kind of familiar from what we've just done, but I want to show you kind of the first steps of what you would do to build your own GraphQL server. If you had any problems finding that or getting that fired up, do let me know. This is way too small, so let me blow this way up. The other thing I want to point out here is in the browser over here, we have a code sandbox or a code sandbox window rather, that will that will show us the GraphQL playground. So that's pretty cool too. Okay, let's talk through what is here already, and then we will take our next steps of designing this thing. So the first thing that we have on line 1 is we're requiring a couple of packages, a couple of functions from Apollo server. So we need Apollo server, and we need this thing called GQL. GQL is going to help us to design our schema. Here on line 5, this is our schema, our type definitions. Think of the GraphQL schema as being this awesome language that we can use to define all of our API's types. Currently, we have a type here called query. Inside of the query type is where all of our queries will go. So our pet library, for example, had an all pets query. That was defined inside of the type query. And then as we talked about a little bit earlier, we also have on line 10 here, we have some resolvers. Resolvers are functions that return data to make our schema work. So if I have a query called hello that returns a string, you better believe there's going to be a function here called hello that will return hello world. On line 15, we're creating our server. So what do we need to create a server? We just need a type definition. So we need the schema, and we need those functions that are going to return data for the schema. And then on line 16 is where we start the server. And let me get our toolbar back so that I can pull up the playground. At this point, we should be able to send the hello query and return hello world. So those are the kind of basics of getting started with a hello world server for Apollo server. Like I mentioned, you don't have to use Apollo server. There are tons of other ones that you can make use of. But nice thing about working with Apollo server is that it creates these really nice maps between your schema and your resolvers. So this is kind of the process that we'll go through as we build this thing together. So hello is very exciting, of course, but really what we're here to do is to model our own data. We have a file here called lifts.json, and we can think of this as being our database. What we want to do here is we want to create, for all of these different fields, we want to create this lift type in our schema. So this is what this will look like. We're going to say type lift, and then we'll add some fields here. So we want to add an ID field. We want to add a name, which will be a string. We'll add a capacity field, which will be an int. Let's just add that for now. And then the next thing I want to do, and get that out of there, the next thing I want to do is inside of the query type, we're going to replace hello with lift count. And this shouldn't return a string anymore. What this should return is an int. So over here in the right-hand side of the screen, we have a bunch of errors going on, which is fine. It's what we expect, actually, because we need to make sure that our resolvers match our schema exactly. So this is what this will look like. We want to create a function here called lift count. And what lift count should return is it should return some sort of int, right? It should return a single value. The way that we're going to come up with this, though, is remember we're importing this lifts array from the data. So all we need to do to make this work is we're going to say lifts.length. At this point, if we open the playground, we're going to refresh the playground as well. And we should see a field here called lift count that returns 11. So we're always, as we're creating our schema, we're making sure that it matches the resolvers exactly. If we say we should return a lift count field, or we should have a lift count query rather, that returns an int, we should have the same inside of our resolvers. Okay. The next query we want to add is called all lifts. And all lifts should return a list of lift objects. And all this has to return inside of our resolvers is it should return the entire lifts array. So over here in the playground, I'm going to hit a refresh again just to make sure that those schema changes have been picked up. And at this point, we should see the all lifts query is now present, and we can add the name and capacity fields and find our objects being returned for each one. Pretty cool. So these resolver functions are really responsible for returning data. They can return data from anywhere. They can collect information from anywhere. So these could make requests for REST APIs. They could find data from databases, all sorts of different cool things that you can do. Let's add on to this a teeny bit. I'm going to create an enumeration type for lift status. And lift status here should have those values we saw before: open, hold, and closed. Once you create this, you can then add a status field that returns lift status. I'll make it required, make it non-nullable. We don't have to make any adjustments to our resolvers at all. We can just go to the playground, add the field we need, which is status. And then we'll see open, closed, and hold for each one. Pretty cool. So just to reiterate, we have our data coming from that database, which is our JSON file. We've created an enumeration type for open, closed, and hold, giving us a restricted list of options for those fields. So I'm going to share my code sandbox. I'm going to fork this because I shouldn't have really been doing that. Let me go way back. I can do that later. Anyway, so that's a quick example of kind of how those two relate. But I also want to pull up this example, and I'll share this link with everybody. I want to share this example where we're pulling some data from a Strava REST API. So if you haven't used Strava before, Strava is an app for tracking your hikes and your runs and physical fitness activities like this. So let's say we wanted to create a GraphQL API that has data. This is the same as before. It has data from our lifts and trails JSON files. But we also want to wrap a little bit of data from the Strava API as well. So that's just a public REST API out there somewhere. And we want to pull in some data from that because we want to kind of stitch it in to this service as well. So we have our lift type, we have our trail type, of course. If I scroll down a little bit, though, I'm adding a type called activity. Activity is a type that is part of Strava, and an activity has a ton of different data points on it. But for my purposes, all I care about is 5 fields from that activity. So the first step is I'm going to make a type inside of my schema that is based on those Strava fields that I want to use. Only the ones I want to use. I don't have to use all of them. Once I've added this type, then I can add a query. So here on line 66, we're adding, or 68 rather, we're adding my activities. This is a query that's going to return that list. So this makes sense. We're adding it to the schema. But here's the exciting part. We, inside of our resolver functions, remember resolvers are just functions that return data. Inside of our resolvers, we have a query key, and then this wraps around all of the different types of queries that we have on this service. Now, the My Activities query is a resolver that's going to return some data for these activities, but check it out. Instead of just pulling data from a JSON file, we're going to fetch some data using an async function, async await. All resolvers can be asynchronous if you want them to be. We're going to make a call to fetch from this API. We're going to pass in some headers. So headers are going to wrap the Strava token that we need to send for authorization. Once we get the response back, we'll parse that response as JSON, and then we'll return those results. So this is really, really cool. We can use data from a REST API and fetch that data right here in this app. So that's something to check out if you'd like to. There's also a tool called REST Data Sources. I'm going to pull up another thing because I love links. And this photo share API is actually using data from a Mongo database. So just as an example, count documents for total photos, find to array. These are all functions that are part of Mongo. So if you're using Mongo or Postgres or whatever you want, you can use these functions to return that data from anywhere. If you take one thing away from this class today, I hope it's that you know that GraphQL can stand in front of any sort of data source. You will create a schema that defines all of your API's types, depending on what those types are. You will then create some queries so that people can access that data. And then inside of your resolver functions, you are going to set the rules around where should that data be returned from, and you can do all sorts of cool things with those as well. So, as we approach the end of our time together today, I'm sharing the link to all of these links. So if you want to stay in touch with us or you want to check out some of these samples, I also have some tutorials and resources, all of which are free at the bottom of the screen here. So Apollo Odyssey is a great tool or a great tutorial site that you can take a look at. It's a great next step from this course. Also, if you haven't checked out howtographql.org, I highly recommend it. It's a great site for being able to kind of do everything from fundamentals to getting started with all sorts of backend libraries and client tools and things like this. So I definitely recommend checking that out as well. All right, so I want to take a second to thank Vista and StepZen for having me here today. I really enjoyed it. Thanks for putting up with how sunburned I am on this screen today. I was outside a lot over the long weekend. So I want to just thank you all so much for being here. Please stay in touch if there's anything I can help with moving forward. I'm happy to hang out and answer questions too after this. We are working on a longer format GraphQL course at graphqlworkshop.com. if you sign up here, there's a email course that you can take a look at. So I just wanted to throw that out there as well. I will drop this here. I appreciate everybody's time so much today. I hope you enjoy the rest of your week. And I'm really excited for you to take your next steps with GraphQL. I hope it's awesome for you. So thank you all so much. There's a couple questions that popped up here, so I will get to those right now. All right, so let's see. So how does the schema definition change if using TypeScript, if there's some sort of a type conflict? So there's a lot of tools for generating schemas and generating types, depending on which way you want to go, based on your schema or based on those types. So I would highly recommend you check out Apollo CodeGen. There's Apollo tooling for kind of generating those types so that if there is a conflict between your types and your schema, you can deal with that through a lot of auto completion. There's another one called GraphQL CodeGen as well that works really seamlessly with TypeScript and your schema and things like that. So definitely check that out. So yeah, if you're got it. So yeah, enumeration types as well. So you'll see how this helps with defining those kinds of types. And I'm not the biggest TypeScript user, but I can totally see how using GraphQL and TypeScript together is a really big win, particularly if you're already using it. All right. Well, thank you all so much for being here today. I am going to drop my you can find me at eve@moonhighway.com. Send any questions there if they come up. But until then, have a great rest of the day, and I hope to see you at a future session. Thanks for being here.